This is problem 14.3.13, and we are not really given a story in this question. We're really just giving a set of ordered pairs, some x and y's here, and asked to calculate a slope and a y-intercept for the data, as well as the sum of squares total and sum of squares regression and sum of squares errors. So with this problem, there's a few different ways that we can solve for the slope and y-intercept. Probably the most simple way is just to use an Excel function. So for the slope, for example, we could use the equals slope function, and then we're going to need to input the y's, which are the dependent variables, and I'll separate it with a comma, and then I input the x's, which are the independent variables. So that is a really quick way to get the slope, and I can back it down to a number of decimal points I want. And for the intercept, same thing, I can use the intercept function and then just key in the same data point, so the y variables separated by a comma from the x variables. Okay, so a very simple way to get the slope and intercept. Notice I just plugged in the formula from the cell. I could have easily just gone into the formula builder here and entered the data this way. So this question, though, also asks for the sum of squares information. So with that, I will just run a quick regression, which is also going to, of course, give us the slope and intercept as well. So didn't really need to do it as a separate function, but just wanted to show you how you can get those figures pretty quick and easily with a function instead. So what I'll do is go to the data analysis option here. I'm going to choose regression. And from our regression box, we'll input the y variables, the dependent variables, and the x variables, or independent variables, and including the labels, which I will enable the label box here. So it states that we are using labels as part of our ranges that we have selected. And our confidence level is default of 95% or alpha of 5%. So this problem doesn't even give us an alpha, but by default we just use 5%. And for the output, I'm going to go ahead and just select a cell over here somewhere. So let's put it right there. And that's pretty much it. We don't really need to worry about any of the other options at this point. It's kind of just a basic ANOVA table is what we're looking for. So when I click OK, here is our output. So as you can see, we have the sum of squares information here. Just highlight that. And that's really all the question asks for. It does certainly, of course, include the degrees of freedom. It's going to include the mean sum of squares, or mean squares, mean squared regression, mean squared residual figures, our f-score, which is significant. You can see that it is less than 1%. And based on an alpha of 5%, we would consider this to be a significant model. And it does also have our r-squared up here, being that it's saying that essentially 93% of the variation in our sample can be explained by the independent variable, which is x. And so this top part of the table here is really about kind of the global model itself, whereas the lower portion, again, the question doesn't ask us about this, but the lower portion is the details of the coefficients, coefficient for x and coefficient for the y-intercept that we use to construct our linear regression equation. And then we have t-stats here and p-values that will help us determine whether or not the variable itself is statistically significant, or meaning that it impacts the dependent variable. So in this case, this is a simple regression, so we only have one independent variable. But as we would expect, since the overall model is significant, of course the p-value we would expect to be significant for our one independent variable. P-value, as you can see, is also less than 1%, matches the p-value of the f-score, since once again it's only one independent variable in the model. So this again just confirms that the x variable, independent variable in this model, is significant at just under 1%, which is better than the alpha of 0.05. Now what if we wanted to solve this problem with XLStat? So with XLStat, we would just go to modeling data and linear regression. And same thing, we're going to select our range, see our y variables first along with the label, our x variables. And you see the labels are highlighted here. And we will choose for the output to go onto a separate sheet, just in case we have any issues with the output, or if we need to rerun the regression for any particular reason, we could just delete the previous sheet and not have to try and pick and choose what we delete off of the sheet that we're working on that has the data that we need, that we don't want to have impacted. So that's pretty much all we need. A lot of the selection boxes may be highlighted the first time you run a regression, especially the charts here. So all the chart options have been unselected, so they won't kind of clutter up the output. And the only output I'm really concerned with at this point is just the ANOVA output, so that's why analysis of variance is selected and really nothing else. So if I go ahead and hit enter, or OK I should say, it gives us the same relevant information that we needed for the problem. So it does give us our sum of squares data here and the same coefficient information and f values and r squares and everything else that the data analysis Toolpak will provide as well.